Hello and welcome back to China Manufacturing Decoded from the Sofeast Group. Adrian hosting today. Renaud's joining me for your first podcast of 2024. Hi, Renaud.
Oh yeah. Hey, well, how you doing? Happy New Year to you and to all the listeners.
It's amazing how quickly it's come around, isn't it?
Hmm. Right. Let's see how fast it goes in 2024.
Oh,
Yeah.
yeah, it certainly does. And on the agenda for us, just before we kick off with today's topic, soon it's CES, and we're gonna have some of our folks at CES. So hopefully see some of the listeners there.
Yeah. Right. I won't be there this time, but Fabian and Kate are going. So, I mean, hopefully they have a few observations also to relate after they're back. But yeah, they're going to
Mm.
be quite busy over there. Number of people to see and so on. So it's going to be intense. Let's not put pressure on them.
No, not at all, not at all. But that's probably sort of a big start to the year anyway. And I think by
Mm.
the time this is published, it's literally gonna be underway. So yeah, that's
Mm.
gonna be exciting. And as you said, we'll come up with some observations from CES as well as what we've been doing as well
Mm.
in due course. Okay, so if we launch into today's topic, cost versus quality and finding a balance between them for manufacturers. So very much in your wheelhouse, Renault. And I know that there's maybe, a few particular points you want to focus on with this. But before we do that, let's just sort of introduce it. So when we're talking about, the balance between cost and quality, how would you quickly describe that?
So you're hitting me with a philosophical one this time, huh? Cost versus quality.
That's it,
Uh,
yeah.
the, there's basically if you are in a classic transactional situation, and maybe you're talking to one of your suppliers, let's say, and you say, well, we need better quality. For example, we need more consistent quality. We need fewer defectives that don't comply with this and this requirement, or we need to have tighter tolerances here. You know, the supplier usually is not going to tell you, "Oh, great, this is going to this is going to push me to do things that reduce my cost. So I'm going to give you a, a price break." It's going to be the opposite. They're going to say, "Well, you're basically raising the bar here, and it's going to be a bit higher, a bit harder for us to hit. So we need to think of the impact on cost, right?"
Mm,
And that's sort of the knee-jerk sort of reaction that you can count on. And it's not entirely for bad reasons. We're going to go over that. But that's typically the first thing they're going to say. Well, oh, wait a minute, there's commercial implications here and, cost implications. Maybe we need to revisit pricing, right? And then you have some, mean, I'm sure you've seen like in places like LinkedIn and things like that. You have people who say, oh, in a lean setup, like in Toyota, they have better quality and lower cost at the same time. This is like
mm,
magical. You just need to follow this is the playbook, and of course, read my book or pay me for. I'll be your consultant. I'll show you how to do that. So how come, right? So you work on getting better quality, then is it going to help you reduce your cost or is it going to push your costs up, right? And really, a lot of it depends on the context, and a lot of it depends also on the engineering resources you'll put behind it. So
mm.
there you go. It's it's a complicated topic. We need to break it down.
Yeah, complicated, but I bet it's something that's often popping into people's minds. And, we want the lowest cost, but we also want the best quality possible that's, suiting our needs as well, I guess. So, finding that balance really it's, well, literally a tightrope, I suppose. So, breaking it down then, what's the first sort of point that you would focus on?
Mm. Well, the first thing, as I mentioned, in a typical transactional relationship, if you say we need better quality, your supplier is going to say, well, we need better pricing, right?
Mm.
And typical things that they think of, and I'm going to think of this and talk about it in the context of China manufacturing. Okay.
Yeah.
Typical Chinese manufacturer is going to think, well, they want better quality, So for example, I don't know, on the last shipment, for example, on the packaging, a few of them, the printing was a bit off, and they saw that, and it was on 10% of the boxes, and they really don't want that. They didn't tell us before they had these requirements, like 0%. They really need, so you might say, well, the standard was already like this. There was some deviation. You have to get to it, but still, they're going to be thinking, well, it means we need to inspect them visually one by one. It means we're going to have to put more pressure on the supplier, also maybe the printing supplier. We're going to have some rejects and send it back to them, and we're going to have to whatever, you know, to negotiate with them a bit, and yada yada yada. All right. In
Mm.
the end, more inspection time, more time from their purchasers to follow up on this, and so on and so forth. That all of that is higher cost, right? If you say, well, this widget that you have, I don't want this molding defect on some of them, like, come on, there's like burn marks, or there's some scratches from when it came out of the mold or something like that. You say, I really don't want that. And of course,
Mm.
supplier is not going to be thrilled. They're like, well, yeah, you're raising the bar. You're asking us to do more work to achieve that result, right? So typically they're going to try to say, well, this comes with a higher price. And this is especially true in China because they Chinese suppliers have, they have their logic, and sometimes it's a bit hard to understand, but really they have a logic. Once you get it, it kind of makes sense. Okay. And in that case, the logic goes like this. If you want, you want high quality, you're ready to pay a high price. If you bargain for a lower price, we can assume that you will accept lower quality, right? But if you bargain for a low price, and after that you give us some chargebacks and all kinds of things because you want higher quality and you push some cost to us and so on and so forth. Well, this is not fair, right? And this is
Mm.
I actually read, I don't know, maybe on the China Law blog by somewhere, maybe Dan Harris wrote about that. In a court of law, if there's no specific and documented quality standard, and you, for example, you're the buyer and you sue your supplier and you say, well, they delivered that bad quality shipment. Well, if the supplier shows to the judge, look, they push for a lower price, and look at the normal price on the market, we are pretty competitive. The judge is also going to tend to say, well, they got what they paid for, right? So in China, it's also a culture where they tend to view things sometimes more holistically and always think of the context. Like when you listen to actually the way they speak in Chinese, it's not very specific. The
Mm.
listener has the responsibility to put things together and to guess certain things sometimes. And it is the mark of, how to say, sometimes a more sophisticated culture, right? Where things are not said very specifically, A, B, C, D. No, there's a little bit of an art, and the listener is supposed to understand what is meant, right? Between
Mm.
the words. And then they look at, for example, the Americans who are very, very specific, who tend to write things like there's no context and try to be very logical and have things flow naturally and everything, logically. Okay. And they look at that and they say, well, yeah, anybody can understand that. This is not the mark of a very sophisticated culture. This is the way, and it's not just China, by the way, right? Korea and some other East Asian countries tend to function like that. So what I'm saying is that they tend to keep the context in mind always, and everything is linked, all right? That's why when you have a dispute with a Chinese counterparty on one area of your relationship, is going to sour the whole relationship usually, right?
Mm.
And that's why when the USA is trying to say, well, let's try to keep the fight for the climate out of our little, trade and tech war, I don't believe it's likely to succeed. Just because the Chinese side, everything's linked. You want me to make efforts
Mm.
here, you have to make efforts somewhere else, wherever, but it's all linked. Okay, so where am I going with that? In their mind, if you talk about quality, it has an impact on cost, whether you say it or not. If you talk about
Right.
cost, it has an impact on quality, whether you say it or not. And that's why it's kind of a fight sometimes when the buyer says, well, this is our standard. And then the supplier will say, well, yeah, but you don't pay for that. And, we need to revisit the pricing. And then you always want to make it very, very clear to Chinese suppliers that it's separate. No, no, like I'm quality. And if you want to talk about cost, purchasing, is the other side of the hallway. You go talk to them.
Mm.
You don't talk to me about pricing. Talk to me about quality. You want to talk about pricing, you go over there, but you don't talk quality with them, right?
Mm.
And quality is non-negotiable because if you start to negotiate quality, usually if a product is already developed, already designed, you negotiate quality down. Usually, it's going to bring you more costs than it's going to save you on the transaction, right? Now,
Mm.
if it's during product design and development, it's different. You can think of how to make the right trade-offs, but once it's in mass production, usually it's too late. You don't want to talk about that. So you want to say, okay, quality non-negotiable. The standard is here. It's documented. It's black and white. You have to sign, and that's it. And pricing discussions are separate and will not have an impact. And you really want them to understand that that's the way you think, because that's the way
Mm.
you want them to think. Okay. So typical Chinese approach to that, yeah, is very, very simple, straightforward. You want high quality, is going to be more expensive. We're going to have to put more inspectors. We're going to have more rejects. We're going to have to scrap more material. We're going to have to do more rework. All of that is cost. One way or another, you're going to have to eat it up, right?
Mm.
If you want tighter tolerances, well, this is our CNC machine, it does milling and that's what you get out of it. If you want tighter tolerances, then we have to do some honing or, some finer processes that will allow for much greater precision, to hit the smaller tolerances,
Mm.
but maybe the cost is times 10, right? So there's a point where the cost like goes up exponentially. And does that make sense, right? So and everybody in their right mind will say, well, yeah, of course we need to think about that. We need to be reasonable, right? So
Mm-hmm.
that's the sort of knee-jerk reaction that you will get if you talk to your Chinese suppliers about, you know, changes and like getting better quality.
But something strikes me here. This conversation, you need to be having this as early on as possible. Because, of
Oh
course,
yeah.
like you just said, if your manufacturer comes back and says, yeah, we can do that, but that's actually going to cost 10 times more than
Hmm.
originally quoted because of the
Hmm.
nature of whatever it is. You don't want to be hearing that when you're, well down the new development process and you got, pretty complete prototypes in your hand and whatever. You want to be hearing that at an
Exactly.
early stage so you can switch out the materials and maybe go in a different direction or something.
Exactly. Yeah. Yeah. I'll get back to that later. Yeah. But that's
Okay.
especially in mass production. You don't want to hear these kind of things. But also, ideally, you would already have set a quality standard that's already tight enough. And of course, you refine it over time, but you don't go crazy. You
Yeah.
don't, if you really change, you go much deeper. You see some issues you were not thinking of. You say, no, like this is our tolerance on that. And suppliers like, whoa, this is really hard for us to hit. There's going to be commercial implications, one way or another.
Yeah. Mm.
So that's what you can expect when you talk about it with your Chinese suppliers.
Hmm.
Now, having said all that, yeah, as I mentioned in LinkedIn, in some books and so on, in some YouTube videos and inspiring stories, you will read here and there of world-class manufacturing, lean manufacturing, whatever, Toyota production system and so on. And there's a lot of good principles and also some good tools to learn there, definitely. But there's often a difficulty getting that back to a specific situation of, hey, we are making these widgets. How do we apply this, right? With the current state of technology, how do we get to one piece flow and things like that, right? And people very often kind of struggle for many reasons, right? But if I summarize sort of the philosophy, right?
Hmm.
The philosophy is that if you focus on the process will lead to higher quality and lower costs, and also shorter lead times. And there's a lot of examples. Usually these kinds of books and videos, they are full of examples of, hey, we made these changes and, we shove lead times down 80%, inventory 90%, cost went down 15%, quality went up, blah, 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 right? And then they say, yeah, we work on the process this way, that way. All right. And we revisited also the supply chain and the exchange of information. And we went from push to pull and okay, we connected the processes and we went to Kanban and things like that. There's a lot of things that can be done. Right. But again, if we try to simplify and summarize, one way to say it is that if you focus on compressing the lead times, you basically you kind of map, okay, these are the activities, and this is the time that the material kind of sits doing nothing, waiting for the next process. And this is where we have a lot of inventory and everything. Okay, how can we compress that? How could we make it so that instead of having, I don't know, a total manufacturing process, and you really want to go beyond your four walls here, right? You want to go and include the key suppliers of custom components at least, right?
Mm.
Just like in a Toyota factory or, most pretty much all car factories, they start from the body shop, getting the steel, um, pressing it and making the structure of the car, and then they paint, and then they put all the fittings inside, assembly. All of that is done in like 24 hours. It's amazing, right? How do they get from from steel rails to finished car in 24 hours? Well, they really thought about all of the steps and how to compress it, how to put them one next to the other, and then the material goes there, and then it goes there, goes there, goes there, goes there. You know, so they really worked on that. They compressed the timelines. The material is transformed, right, in a logical way, without waiting too much. So if you
Hmm.
work on compressing the timelines, one thing that will happen is that you will have better quality because, if you pay attention to quality, oh, we see this kind of defect here. Let me have a look. Oh, this one also here. Okay, let's go right to the process right now. That process, the upstream process. So, for example, I don't know, in the body shop, let's say, okay, you see after welding, oh, there's some issues here. Let's go straight to see that automatic welder, what's going on, or the way the robot grabs the part or something. Let's have a look at the process. And the good thing is the defects we see now, because we're going to do something with these welded parts. Okay, so we take them, we touch them, we try to fit them or whatever. Oh, we see something right now. Well, that part that I'm looking at and I see the defect, it was welded just 5 minutes ago or 10 minutes ago. right?
Mm.
So I can look at the process right now, and then if I see there's some deviation, okay, we can act on the process right now, but it doesn't make like a pile of 10,000 parts that will all have the defects, right? Which is a huge source of problems in the typical batch and queue, make a big batch and have them in a queue for a long time, right? Call it batch and queue.
Yeah.
That's a huge problem, right? And then when you have 10,000 parts that were whatever stamped, and you look at them and you're like, oh no, it was a bit off, whatever. Maybe the fixture was not set up properly, or like, the tool was already a bit too worn, or should have been changed earlier. Ah, then what do we do now? Right?
Yeah.
We have
That's a
the
lot.
10,000 parts. And the temptation is very strong to just, okay, just use them in production. Let's hope there's no big problem,
Mm.
right? So when you compress the timelines, you have this effect of we find a quality issue and the trail is still hot, and we're going to get to the source of the problem, and we're going to observe the process, we're going to understand, and we're going to fix it right there before there's a lot of, strong impact. And then once you have that benefit, well, all of that is going to lead to lower costs. Well, first you have much less inventory, right? Because you don't have that much material waiting, because it's just like it's made, and then 5 minutes or 10 minutes later it's transformed again in the next process. So it doesn't sit there, and you don't have like thousands and thousands of parts waiting for the next process, right? So less inventory means you need less space. All the inventory, there's changes of orders, and there's, they get damaged, they get lost, any kind of problems happen, um, right? They get in contact with each other, they get dented, all kinds of problems. All of that is cost. You need like a big warehouse to put it. You don't need a warehouse anymore, right? You save a lot of rent. So lower inventory definitely leads to lower cost. Also better quality, as I mentioned. You're going to find the source of the issue, and you're going to be able to root cause analyze it, and fix it for good, hopefully. And that means you don't need
Mm.
to do as much rework. You don't need to scrap as much material. What that is an enormous amount of saving right there, right? So these are just two examples. So you compress the timelines, you use that to reduce inventory, to improve quality, and then if you do these things right, you will have lower costs. And of course, that is a logic that one cannot really argue with, right? It just makes so much sense. There's no way to say that it doesn't happen. The problem is that it takes often a lot of engineering work, and also a factory cannot jump from a traditional setup to a very advanced lean setup immediately. Or maybe it can with, the intervention of very good consultants, and, full engagement of all the management and everything. But then if the people don't understand it, the engineers don't understand it, then when the consultants are gone, when the managers get busy, well, the people are going to run it like before, right? You can't just jump to it. It takes years to go to that, and 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 it always depends on the limits of technology and what really is feasible here or there, right? So you can't just
Mm.
say, okay, it's going to be just like a car factory. um, Not really. Well, one car factory, first, it only makes cars. Second, it usually makes cars on one or two platforms, but it doesn't make very different cars, right?
Mm.
It needs to be, it's very focused. It always goes through the body shop, the panel shop, and then it goes to paint, and it goes to assembly, and it's always the same kinds of things that get fitted inside, and the same way that is visually inspected and tested and so on, right? Uh, can't really take so many direct observations back to your factory usually. A lot of
Mm.
ideas that are inspiring, right? But you need to adapt. So that's sort of the idea of world-class manufacturing, excellent process manufacturing. Uh, of course, you can work on your processes and you can have better quality and lower cost and shorter lead time altogether, right? There's a lot of examples of that. However, can you go to your colleagues in manufacturing tomorrow or to your main suppliers and say, well, just go visit the Toyota factory, just learn about that and just apply it. And then next year, I want to see a 10% decrease in cost and 8% every year after that.
Mm.
No, you can't. You can't. You can't. It's really not that simple. So when you actually look at the day-to-day realities, I think what we should mention is that there are some keys to focus on that will give you some leverage, right? And
Hmm.
there's a few that I'm going to mention here. It's not an exhaustive list, but this is what comes to my mind. And these are things that will help you reap more consistent quality and also cut costs if you do it well, right? But again, you need to pick the right keys for the right application, the right solution. I mean, the right situation, right? It doesn't all help all factories equally, of course. So
And is this is based on maybe a more typical Chinese manufacturer, not someone who is like a world-class auto
yeah, yeah,
one.
yeah. This
Yeah,
can
yeah,
be
yeah.
right. This can be implemented in a lot of different types of factories. Yes.
Mm.
So the first one, and let's kind of follow the product life cycle, right? Let's start when the product is getting designed,
Okay.
is to actually do design for manufacturing and assembly. I think we discussed it on this podcast before. I'm not sure,
Mm.
but otherwise,
Yes, and in some videos.
yeah. Yeah, we have videos about that. Also, if you do a concept design and a nice industrial design and so on, and then, okay, we have a prototype, and then let's just push it to manufacturing and, get the manufacturing people to just do it. Don't ask us any questions, just do it. Well,
Mm.
they're going to do it, but maybe the full cost of production is going to be 30% or 50% higher than what it could be if some small changes were made that actually would make it, again, easier, faster, cheaper to make the product.
Mm.
And there's a lot of examples of that. I mean, probably the simplest example is that instead of trying to custom develop something, try to pick something that's already available, commercial off the shelf. Um, Chances are, if it's made in decent quantity, sorry, by a relatively good manufacturer, you know, its quality and its cost will already be lower, much lower sometimes than what you would custom design and custom manufacture, right? This is just one example, but there's so many other examples, right? If you make this little change like this, then we can machine it that way, and it's going to be twice as fast. But if you really want it to be that way, then yes, we need to do this and then load it to that other machine and blah blah blah. It's going to take a lot longer. Oh,
Mm.
okay, all right. And there's so many, so many, so many examples of that, right? If you don't do DFM at all, you might end up with, I don't know, like powder coating, aluminum color, and then you have 20% reject on certain types of surfaces. This is just an example. You just make it much more likely to have certain types of defects, right? So design for manufacturing and assembly, definitely that will typically give you an excellent return on your investment. So take a bit of time and put some attention and resources into it. It's worth a lot, right? It will give you very good benefits.
Mm.
Another one that we mentioned multiple times on this podcast, and especially for electromechanical products, is a good process for new product introduction for EVT, DVT, PVT, whatever you call it, industrialization. How to industrialize the product, right? So basically, you work on the design of your product, you design it for manufacturing. Okay, it's not enough. You need to actually spend some time to design and validate the manufacturing process, the testing process, in a very logical way with gates, go, no go gates, and so like systematically. And if you invest, okay, let's take two examples. Small startup coming out with a new product, no idea if it's going to work. This is going to be version one, so anyway, they're not going to make it into the millions. They already have some ideas for version two that they would make better, right? But they want to push version one onto the market, get some feedback, start to get their name out there, reassure the investors, everything like that. Are they going to have 20 people coming down to the manufacturing site, spend 3, 4, 5, 6 months there, do a lot of work during, uh, you know, basically from the end of product design all the way to start of mass manufacturing, and then even after that, keep fine-tuning things and so on. No, of course not. It doesn't make any
Mm,
sense. They want to
mm,
keep it simple, go fast, right? Now, there's a certain trade-off. You don't want them to go too fast because then, they might really have serious quality and reliability issues. So you don't want to skip too many steps, but you want to keep it relatively simple, right? Now,
mm,
on the other hand, you have companies like Apple and others, right? When they develop a new product, they have an army of people, right, working there, and they make sure that the project managers and all the team on the supplier side also is top notch and following their NPI process and filling out all the documents and everything, right? Same thing when you develop a automotive part that will go into a car that hopefully has a lifetime of 3 to 5 years and will be made at a volume of whatever, 100 to 300,000 um, cars per year. Well, it, it pays to put more engineering resources at the beginning, right? To get,
mm,
again, the manufacturing process and the testing process to the level where you have really the assurance that the products will meet your quality standard, will be quite consistent. Okay, so you have two extremes here, and you need to figure out where you fit in there, right? But if you have relatively high quality requirements, you have to be honest with yourself. When you develop your product, you really need to ensure you're going to have a good NPI process, right?
mm,
Some of the keys, like for example, and this is related, of course, good tooling, good fixtures, dies, tools, and also when you start with that, you go in the direction of semi-automation, and then later, more like full automation. That is some of the engineering work that I mentioned. Well, good tooling saves a lot of time. Even in looking at assembly, I mean, in our assembly lines, there's a lot of fixtures, a lot of testing stations and things like that. You ensure that the operator is going to place the part the right way into it, and then he keeps it in a certain way, and then the operation is much, much more accurate and much, much more repeatable, right? If you don't do that, and people do it with their hands, well, it's a little bit freestyle, right? So you're going to have some variation.
mm.
And end of the day, people are a bit tired. The line leader is looking at some kind of problem somewhere or whatever. The variation is going to become such that maybe the customer will not be happy. So as much as
Mm.
possible, um, you need fixtures and jigs and things like that. It helps a lot, both with quality and with usually with efficiency and cost also, right? Because people don't very often in these types of operations where the operator will like fumble a bit and it's a bit difficult to fit in there, and it's a bit of an art. Um, Usually it takes way too long, and there's a high rate of quality issues. And sometimes, yeah, just a very simple fixture, sometimes pop, now it's three times faster and it's always good.
Mm,
So this is really uh, some engineering like this that's really like magical in terms of results, right? Or
mm,
mistake proofing and all of these kind of things, right? Very, very helpful. Um,
absolutely.
Another one is kind of obvious, but staff training. You have the basic staff training. So, for example, for the operators, okay, what kind of operation do I have to do? How, oh, I'm going to take the part here and then like apply the adhesive this way, and I need to have a visual check that it doesn't go here. Okay, and then I, I, I put the other one on top, and again I press like this, and then I do a visual check like this. Okay, and then I pass it to the next station. Right, this is basic training, and of course, this is something that they have to internalize pretty fast. But and they should do it also on a pilot run first, not right away in mass production. But this is
Mm,
kind of basic. But the training that people should um, be trained to recognize certain types of defects. For example, they have a defect board, like a defect library, just next to the line. And they have to have a quick look at it every day to keep it fresh in their minds. Well, when they see a certain kind of defect, maybe they put it in a red box right there just by the assembly line. And somebody has to, like a line leader or a quality engineer or somebody should see, oh, there's two of them already in the red box. What's going on? Right away,
mm,
we have to go, it's kind of escalates on its own, oh, okay, what is it? We need to start some kind of inquiry here, investigation. What is the point of cause? Can I see it? Um, how to make sure that it's just on two pieces, not more than that. Let me have a look, etc., etc., etc. Right? When you have this kind of um, automatic reflex, that really helps. Right? Again, catch the issues early, go to the point of cause, observe it, try to understand the root causes and things like that. That will help with quality and cost, right?
mm,
There's a number of other things. Maybe I should mention very quickly experience effects. If you make the same kind of product, thousands and thousands and thousands and thousands, it makes sense to have a more comprehensive NPI process. But also once it's in mass production, it makes sense to have again process engineering, industry engineering, and so on, and also quality engineering resources to work on it to look for ways to keep improving the process, right? And naturally, through experience effects, anyway, costs will tend to go down. But again, this is very, very variable from production to production, the way it's set up. Okay,
mm.
so I could go on and on, but these are the top ones that came to my mind basically. Yeah, to have some leverage, right? There are some levers that you can pull and it will impact both cost and quality. As a conclusion, maybe we should I remember some discussions we had
Mhm.
over the years with Chinese suppliers, but also in some seminars with some buyers saying, oh, how to work with Chinese suppliers, how to get better quality but lower cost, and should we like penalize them? Should we charge them back, etc., etc. And I remember David Collins, who was the director of consulting at China Manufacturing Consultants. I remember one thing he said, and that kind of stuck in my mind, and it's so true. He said, "Look, you can't oppose cost and quality. Um, when you're the supplier, cost gets you the business, but quality allows you to keep the business, right? With cost, you get the business in the first place, but then after that, you want the customers to keep coming back.
Mm,
So you need to have consistent quality anyway. You need both, and these are both sides of the same coin, right? If you want to succeed in business, you gotta have both. You can't just say, "Oh, we're high quality, but we don't care about cost," or we're low cost but we don't care about quality. There's certain markets where maybe quality doesn't matter or cost doesn't matter, but in the end you're going to have pressure on both and you need to work on both usually.
Wise words to consider for sure. I like it. So, good conclusion there, Renaud. That concludes today's podcast. And yeah, thanks for going through, the cost versus quality question. It's a good one to think about.
Thanks.
We'll be back next week. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.